Hey guys, talking about the calculations in the copper wire reaction, which is the one you're going to work on this week or are working on, the chemical reactions of copper. All right, so there's 5 reactions that you would have done in lab. The first one would have taken copper and turned it into copper nitrate, a redox reaction. Then the second reaction would have took your product, copper nitrate, and turned it into copper hydroxide, a metathesis reaction. Then we would have heated the copper hydroxide, all right, used this product to start reaction 3, heated it, dehydrated it, and turned it into solid copper oxide. So you would have had wire, a green solution, okay, with a brown gas coming off in reaction 1. Then you would have had a blue solution of the copper hydroxide. The copper hydroxide solid would have turned black when it turned to copper oxide. Now copper oxide would then be reacted with H2SO4 and the black stuff would just disappear and you'd have a clear blue solution again, which is my copper 2 sulfate. Then we would take that product and do one last reaction to get the copper to drop out, a redox, so this is a double displacement reaction, and then we would have did a redox reaction and had the copper fall out of solution, reacting it with aluminum. So the question is, well, what do I have to do here? Well, we could figure out the grams of each product, and there's a reason I put them in red, because this other stuff is arbitrary, it's excess. We're really focusing on the products and reactants that contain copper. The products of reactant 1 start reaction 2. The products of reaction 2 start reaction 3, and so on. So, you're going to start with 0.5 grams of copper wire. And the question is, how much copper do you expect to get out at the end? And along the way, I want you to calculate how many grams of each of these products should you have suspected in your reaction. Okay? Ideally, if I start with 0.5, I should get 0.5 out at the end. Okay? But I want to see also the grams of each one of these components along the way. So, you're starting with 0.5 grams of copper. My first step is I got it to copper nitrate. So I've got to convert my grams of copper to copper nitrate using my stoichiometry. This is chapter 3 stuff. So you're going to take 0.5 grams of copper, use the molar mass to get the moles of copper. Then you're going to use your mole ratio from the balanced equation, 1:1, and figure out your moles of copper nitrate. Your moles of copper nitrate, okay, and using the molar mass of copper nitrate should get you to the grams of copper nitrate. And there's step 1. Now, how do I continue? All right, you want to continue? Boom. Step 2. How many moles of copper nitrate did I end up with? Whatever your math says, that's what you have. That also tells you then, move it here. This amount starts this reaction. So let's just say, for instance, this ends up being, and I'm making up a number here, this ends up being 0.3 moles. Then that's what's starting this reaction. You have a 1:1 relationship. Now find the grams of copper hydroxide. How many moles are here? 1:1. Okay, if this was 0.3, then this should be 0.3. Start that here. It's 1:1 again. This is 0.3. Figure out how many grams using the molar mass of copper oxide. And so on and so forth. To do your theoretical yield, you go all the way through until you get to this copper here. In theory, if the math works out, 0.5 you started with, you should end up with 0.5 at the end. Okay, so you'll know you did all the math right if you started with 0.5 here and you end up with 0.5 theoretically. Now, I'm going to give you an experimental value also so that you can find your percent yield and your percent error. Percent yield is going to be your copper you calculate doing this way. Okay? So your percent yield, remember, let me just do it this way, it's going to be easier. Percent yield is your actual divided by your theoretical times 100. So I'll give you an actual experimental yield that you would have gotten in lab, and you'll put it over whatever you calculate your theoretical to be, which should be 0.5 from what you're starting with. Your percent error is equal to the absolute value of 100 minus your yield. Okay, so you have a lot of stoichiometry to do. So your first stoichiometry is get copper to copper nitrate. Whatever your moles answer is here, okay, you are going to take it another step and convert it to grams. But whatever your moles answer is here starts the stoichiometry here. Mole relationship to here, whatever your moles are here starts it here, to here, to here. But if you notice, it's all 1 to 1 to 1 to 1 to 1. So the only thing that should change throughout, okay, the number of moles here should be here, 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 because it's all 1 to 1 relationship. The only thing that should change is how many grams of copper nitrate should I have gotten out, how many grams of copper 2 hydroxide should I have gotten out, how many of copper 2 oxide, so copper 2 nitrate, copper 2 hydroxide, copper 2 oxide, copper 2 sulfate, and grams of copper. Okay, so you're just doing stoichiometry. Answer here starts here. Answer here starts here. Answer here starts here. Answer here starts here. Answer here is your theoretical yield. So hopefully that helps you. If not, you know where to find me. You can reach out to me or you can reach out to Miss Jacobs. Thanks, guys, and I'll talk to you tomorrow.